Okay, we have a couple of responses. Very good. Others, please see if you can verify that. It's a deceptively simple problem. Not okay. We'll check. Okay. Just quickly go through the attendees once again. Any name I might have missed. Gagan's name I didn't. Mhm. Okay, so let's see. All of you can see the screen, right? Okay. So initially, this is at equilibrium, right? Let's say the whole setup has some mass m. So you have downward force mg acting at this point, which is balanced by some equilibrium extension, let it be x naught. Okay. Now you're pouring water of density d into this U tube. How much water are you pouring? Let's say you're pouring some distance x, or sorry, some level x you are adding to it. Let's say up to this point. This level is x. So how much water is this? The cross-section area is given S. So x into S is the volume that you're adding. Multiply that by the density, that will give you the mass that you have added. Multiply that by G, that would be the extra force that you have exerted by adding water, right? So basically what will I get? The new mass will be M plus XSDG. This would be the new mass, and this would be also at equilibrium. So this will be K into X plus X naught, right? From equilibrium, you have added the same distance X. It gets pushed down because the level X remains same. So let's say if it was without the spring, you added some water, and this is the new level of water, right? The water level rose up by X. But at the same time, if the spring also gets pushed down or gets extended by further X, in that case, the water level will not change with respect to the ground. Okay. So the extension in the spring is also X. So I can cancel the equilibrium condition, the previous equilibrium condition. Look at the new X equilibrium. What will I get? X into SdG. I am having twice of it, right? Because this is the total amount of water that I'm adding. So 2x SD into G should be equal to K into X. You can cancel X. So we get K is equal to 2SDG. Is indeed correct. Okay. The level of rise of water is equal to the extension in the spring. So therefore, with respect to the ground, water level does not change. Fine. Let's look at the next problem then. Right.
So in the first case, is the speed a constant value or is it dependent on the extension? So I'm getting like a function in terms of the extension.
The question is stating that it is moving, this end is being pulled with a constant speed of 5 centimeter per second. So yeah, you should get as a function of extension. And then you can put the extension of 1 meter at t equals to 0.
So we need initially.
Yeah, at this instant, what is the speed?
Oh
So the
yes.
whole, yeah, the whole spring is being stretched, but the stretching is not uniform, right? You can see at this end of the spring has to be fixed, so it has 0 velocity, whereas this extreme end has some velocity 5 centimeter per second. So you can assume the speed to be linearly changing from one end to the other end, from 0 to 5.
Yes, sir.
So you can assume a linear function and then solve it, get the answer. Right. Part B is fairly easy. You can calculate the total extension, multiply by the spring constant. So that's good. Part A, yeah, Avnish has got it. That is correct. 5 by 3 centimeter per second. I'll give you 2 more minutes to work it out, see if you can get it. But it's fairly easy. Once I assume it to be a linear function, then you can solve it. All right, let's see. Where is it? So like I said, here the velocity is 0 and here velocity is 5 centimeter per second. Let's assume that it is linearly changing from 0 to 5. So I can say my velocity as a function of, let's say, distance x from here, right? At any distance x from here would be, let's calculate the slope basically, change in velocity over change in x. So that will be 5 minus 0 by the change in x would be 3 minus 0 from here to here into x minus 0 basically, because at x equals to 0, v is 0, right? And x equals to 1, then basically we put x equals to 1 here. So you'll get V at x equals to 1 would just be 5 by 3 centimeter per second to the left, right? So that's part A. Part B is easy enough. Spring constant is given. Extension would be 10 centimeter into 0.6 Newton per centimeter gives you 6 Newton as the force, spring force. Okay. Again, very easy. Okay. Anyone has any doubt here? Okay. Let's look at these first few problems were fairly easy. Let's look at the next one now. Okay, this one is also think about this one now. You can write your answer just in terms of theta, right? It's not necessary to evaluate with 5 degrees. So the answer in the DPP is given in terms of by converting 5 degrees to radian. But that step is not that important. Just in terms of theta, if you can find, that is good enough.
Sir, I have a doubt.
Yes, go ahead.
In this case, can we approximate sine theta as theta? Because theta is a
Yeah, you
very.
can do that for the last step. Yeah, correct. You can approximate cos theta as 1, sin theta as theta.
Sir, climb through a distance S is the path length or the vertical displacement?
It's the distance on the inclined plane.
Okay, sir.
We have a couple of answers. Arjun is saying t by square root 1 minus theta. Yeah, that is right. 2s by theta plus g divided by 2. It's hard to read what that is. I think, yeah, I get what you've written. Theta plus g by 2s by t square plus g. Ah. Two s divided 2s minus. Okay, we can see. I'll give you 2 more minutes. What does this mean? Takes at least t seconds to travel through a distance s on a flat concrete road. That means that is the minimum time, right? So just answer this. On a road, let's say you have a car. I don't know, just draw some random. A car which can travel with some acceleration a. What is the maximum acceleration of this car on a road?
Mu g.
Yes. Right. So this maximum acceleration is mu g. Right. Any more than this, the tires will start slipping. So the maximum acceleration it can have is mu g. So on an inclined plane, which makes some angle theta, what would be that maximum acceleration for minimum time? So your friction force, sorry. Again, just assume some box. What is this acceleration? Let's call it A prime. Downward force you have is mg sine theta. Downward force you will have is mu mg cos theta, the maximum frictional force, right? So, wait a second. Mu g is the forward acceleration, forward friction, right? Because the tires are trying to spin backwards, the friction is acting in the forward direction, which is mu mg cos theta. So what is the net acceleration then? You will get mu g cos theta minus g sine theta. This would be the acceleration on the inclined plane. Okay, so use these things and then try to solve. Mu value is given as 1. Theta, assume it as small theta. Those who got it with theta, now you can try to put theta is equal to 5 degrees, which is 5 into pi by 180 radian. So that gives you pi by 36 radian. Because your answer, final answer is given in terms of pi. Okay. Couple of minutes to work it out. You will not get s in the final answer. Right? You are equating both the distance s. So here, this distance on the flat plane, where is it? Flat plane would be s is equal to half a t square. On the inclined plane, you have the distance s is equal to half a prime t prime square. So just equate the two s, right?
So why is the maximum acceleration mu g?
Because we're talking about a car, right? Car relies on the friction between the tires and the road. If it was just, if it's an object like a rocket or something, that can have as big an acceleration. That depends on other factors. When we're talking about vehicles running on road, right? The forward force here that acts here is the friction force, right? The engine of a car, what does it do? It rotates the wheels, right? And then it's the friction which is acting between the tires and the road, which is propelling the car forward. Right?
Oh,
What is the maximum friction force possible? That is mu mg of the car. Divide by mass, you'll get maximum acceleration as mu g. Is it clear?
yes.
Okay. Same thing for an inclined plane also. Okay. Okay, so just equate the two distances. What will you get? Where can I write? I'll write it somewhere here. So S is equal to, I'll use a different color. S is equal to half a t square is equal to half a prime t prime square, right? Both cases we are starting from rest. Then we will get t prime is equal to a by a prime into t under root. We have written down what is a and a prime. So this becomes t prime is equal to mu g divided by mu g cos theta minus g sine theta. This is inside the root. This is t. G you can cancel everywhere. Mu value is 1. So basically you have t prime is equal to 1 by, so I'll just write t here, t by square root of cos theta minus sine theta. Okay. So in general, this would be your result. And if mu was some other value, you can just have t by root of mu cos theta minus sine theta. That would be your, there will be a mu in the numerator also, right? That would be your general result. For this particular problem, theta is given to be a small angle 5 degrees, which is pi by 36 radian. And for small angle, we can assume t by, I'll just take cos theta as 1 and sine theta as theta. And substitute the value of theta, we'll get t by 1 minus pi by 36. So that is 6t by 36 minus pi under root. This is the answer given in your DPP. Is it clear? Okay.
Can you write the root acceleration, root a by a1?
Yeah. Are you asking this part?
Yeah. Like, can you explain how we got the?
No. I'm just equating the two distances. No.
Oh, acha, हाँ, yeah.
It's the same distance it's traveling on the flat road as well as the inclined road.
Oh, okay, yeah.
So
Makes
just equate the distances, you will get this equation.
yes. Okay.
Okay. Any other problem or any other question in this problem? Okay, if not, let's move to the next one then. Okay. Work this one out. You can tell me a range of mu or the value of mu in terms of the given quantities, right? For example, in terms of V naught, G, and L. Right, that is correct. So she has written the answer V square by GL greater than mu, or mu less than or equal to V square by V naught square by GL. Okay. Okay. A couple of more minutes to just for others also to get the same answer. Then we'll discuss. Okay, let's see. Right. Cloth is lying on the table and we need to say what should be, or we need to find what should be the mu value, the coefficient of friction between the block and the cloth, if the block remains on the table after pulling the cloth out, right? That means the most that this block has to travel, it must be L by 2, right? If it travels more than L by 2, then it will be, then what will happen? It will fall off, right? So the most that the block should be able to travel is L by 2. Initially, the block is at rest, right? And the cloth is moving, right? So we can look at it in the different frame. Let's go to the cloth's frame of reference, right? So in the frame of the cloth, right, it is being pulled by V naught, but in the frame of the cloth, it will be remaining at rest and the block will appear to move in the opposite direction, right? So we will give an initial velocity, even the block is at rest and the cloth is moving. In the reference frame of the cloth, we'll give a velocity to the block, which is V naught, initial velocity, right? But because of the cloth, it has an acceleration in this direction, which will be equal to mu into g, right? Because it is moving, that's the maximum acceleration, right? So your initial velocity is V naught, acceleration in the opposite direction to that V naught, and this distance that you're traveling should be By the way, what is the time it takes for the cloth to be pulled out? Let's say the time is T naught, right? T naught would be equal to L by V naught, right? The length of the cloth that needs to be pulled out is L, and the speed is V naught. So the time it takes for the entire length of the cloth to be pulled out would be L by V naught. In that same T naught time, this block should not travel more than L by 2 distance with respect to the cloth, correct? So in cloth's frame, okay, cloth's frame block should not travel more than L by 2. So we can write down its distance is V naught into T naught minus half mu G into T naught square. This distance should be less than or equal to L by 2. Okay. Let's substitute what is T naught here. What will I get? V naught into L by V naught minus half mu G into L square by V naught square is less than equal to L by 2. So I can rearrange and write this distance should be less than L by 2, right? Correct. So this gives me and also I can cancel. I'll get 1 by, okay, 1 by 2 should be less than equal to this distance should be distance should be greater than L by 2. That is the problem, right? In the cloth frame that we are talking about, not in the tables frame. In the cloth frame, this should be traveling more than L by 2 so that it can get off the cloth. If it doesn't travel, if it travels less than L by 2, then it is getting pulled along with the cloth. So it will basically come out of the table, right? It will fall off the table. So this should be greater actually, not less. Now it will make sense. So 1 by 2 greater than equal to, what is this? 1 by 2 mu G L by V naught square. 1 by 2 also you can cancel. Sorry, this is mu. So you will get, there's a G here, right? Mu should be less than or equal to V naught square by GL. Correct. Okay. This distance that it has to travel in cloth's frame should be greater than L by 2, not less than L by 2. If it is less, then it will get pulled out of the, it will basically fall off the table along with the cloth. Fine. Okay. Let's now move to the next problem. I hope this is clear. Okay. Okay, this one should be easy enough. Please work this out. I'll give you 3 minutes for this. Correct. Very good. Okay, let's see. Did everyone get it? Okay, many people have got it. Very good. So this is fairly easy now. Just look at the graph. It starts moving when the applied force is 6 Newton, right? So this would be your maximum friction force, right? F max or F limiting is your 6 Newton. And once 18 Newtons is applied, the acceleration is 3 meter per second. So the net force would be 18 minus 6, the maximum friction force. This is equal to mass into acceleration, which is 3. So that gives you 12 is equal to 3m, or m is equal to 4 kg. Okay, very simple. Let's look at the next problem then. Fine. Okay, so this one. We have one response, but think again. You need to think in terms of relative accelerations. Okay. Okay, let's see. Some things need to be clear here. Let's label all these points, okay? Let's say this is the end. So this, I'll call this point as E. Let's call this point as P, right? And this is the disk, so that should be D, okay? Now, clearly, if this force F is applied on this string, the same force F would be here also, right? So let's write everything in vector form. Let's say this direction is I cap. So opposite to it would be minus I cap. Okay. So we know that you have two forces acting on the disk. So acceleration of the disk would be 2F by M I cap. Correct? Fine. For this point P, where mass M is situated, you have this force acting upwards, right? So its acceleration, what would it be? Acceleration of point P would be equal to minus F by M I cap. Correct? Because its force acting on it is F. That's the only force acting on it. It's along minus I cap direction. So its acceleration is F by M along minus I cap. Correct? So I can find out the acceleration of point P with respect to the disk as AP minus AD. What will I get? Minus F by M I cap minus 2F by M I cap, which gives me minus 3F by M I cap. This is the acceleration of the point P, or the mass with respect to the disk. Now applying the length constraint on the other end, right? Point E. If this string is going up with respect to the disk, this part of the string will be going down, or let's say if this is going to the left, this is going to the right, right? It's increasing with the same rate. So I can say acceleration of point E with respect to the disk must be equal and opposite to acceleration of point P with respect to the disk, right? This is nothing but the length constraint. With respect to the disk, if this is going up, going to the left, this end has to go to the right. So if you apply that, what will you get? 3F by M I cap. But this is with respect to disk, right? Which I can write it as AE minus AD, which is equal to AE minus, what is this? 2F by M I cap. So what is the final answer? Therefore, AE is equal to, send it to the left side, you will get 3 plus 2, 5F by M I cap. The answer is 5F by M. Is it clear to everyone?
So could you explain the length constraints again?
No, that is simple. No, let's say you have a pulley, right? If the pulley is at rest, let's say this is M1 and this is M2. If the pulley is at rest, if let's say M1 is heavier than M2, this will go down and this will go up at the same rate, right? Is acceleration of M1 down will be the same as acceleration of M2 up. Why do you get that? Because this is connected by the same string. This string has to go up, that means this string has to go down, and vice versa. Correct?
Yeah.
So if the pulley is moving, let's say the pulley has some acceleration AP, then what do? You go into the frame of the pulley, right? You consider like a lift, which has the acceleration of the pulley. So with respect to the pulley, again you apply the length constraint. So what will you get? A1P will be negative of A2P. Negative because they have to be in the opposite directions.
Okay, got it.
Okay. Any other questions? This is clear to everyone? Since nobody got it, that's why I'm asking. Right? I haven't done anything, just wrote everything in vector form, even though it's just in the same I cap direction, I cap and minus I cap, right? But writing like this ensures that you will not make any mistake. Okay. All right. Let's move to the next problem now. If this is clear. All right, let's see. Let's read this and try to solve this. Okay, we have one response finally. So can you tell me how you worked it? What is the method? Just briefly, if you can.
Yes, sir. So the mass of bucket A remains constant, which is 2m, and the
Okay.
mass of bucket B is 2m minus mu T.
Correct.
And then I got an expression for tension, T minus 2 mg is equal to ma.
Okay.
And then I eliminated the variable T, and then I got, it says when the mass of bucket B is 0, so I got T as 2m by mu, and then using these things, I got it.
So the first step is correct in that you wrote down the masses of A is constant anyway, B as a function of T, right? So you'll get 2m minus mu T. That is correct. Now you can directly use the formula for acceleration, right? m1 minus m2 by m1 plus m2 into g.
Yes, sir.
So you'll get an expression for acceleration as a function of time. But the question is now asking velocity, right? So how will you get velocity from acceleration?
Sir, in v is equal to u plus at, I use that.
But the acceleration is not constant, right? It's a function of time.
Yes, I get it.
So you need to integrate.
So the integral I got, I'm not able to solve it because there's a t in the numerator and in the denominator. And the denominator has some subtraction. So
Okay, there is a trick involved there, but you can try different things. You can use a change of variable. That might help.
yes.
Yeah. Okay, I'll give you 3 more minutes to work out the integral. Your answer will include natural log, okay, ln. Actually, I can just set up the problem, just do the integration. So like you said, the mass of A is 2m, mass of bucket plus sand. Here sand is leaking out at a constant rate of mu. So I can write it as at a time t, this will be 2m minus mu t. So using the formula, A is equal to m1 minus m2 by m1 plus m2 into g. I'll get the expression for acceleration as m1 minus m2 will just give me mu t divided by 4m minus mu t into g. This I'll write it as dv by dt. That is acceleration. Rearranging gives us dv or v, directly I can write v is equal to integral of mu t by 4m minus mu t mu gtl, right? Mu gt into dt. And what are the limits of the integration on the right side? That will be 0 to the time it takes to empty the bucket. So let's say that time is t naught, which is just m by mu, right? So m by mu. I'll just put t naught here. Finally, we'll substitute what is t naught. Now, the question is now just to solve this integral. So how to solve this integral?
So what variable will you take for this integral? Not getting that. Like, do you take mu t as something or like gt as something, and then
You can take 4m minus mu t as a variable. And you can take this g outside, right?
g is constant. Okay, fine.
G is a constant, right?
Okay. And then we change the limits accordingly.
Or you can substitute it back and keep the same limits. That is up to you.
Okay, yes.
Okay. Please work it out. Okay, it's just calculation, so let's work it out. So like I said, you can substitute something here. You can take 4m minus mu t as a variable, but what I will do is I'll just use a trick here. I'll write this integral again. V is equal to g into 0 to t naught. I'm going to write it as minus g, right? Denominator, I'll write it as mu t minus 4m. Okay. Numerator, I'll write it as mu t minus 4m plus 4m. Okay. Into dt. The first part will just give me 1, right? So this just becomes minus g of integral dt from 0 to t naught. And the second part gives me minus 4mg integral of 0 to t naught of 1 by mu t minus 4m dt. Right? So this is equal to minus gt naught minus 4mg. This is just natural log of mu t minus 4m, but then I have to divide by mu, right?
So how did you reach the second step from the first step?
You can see here, right? I just subtracted and added minus basically 4m, minus 4m plus 4m. So
Oh, yes.
I split this into two parts. This is just 1. So this is just integral dt. And the other part is 4m by mu t minus 4m.
Yes.
Is it clear now?
Yes, thank you.
Okay. Now this integral is just natural log of this, and but you just have to divide by mu. Okay. And I can keep the same limits 0 to t naught. So 0 to t naught. So let's substitute. So minus gt naught minus 4mg by mu. And this would be ln mu t naught minus 4m divided by minus 4m. Correct? Right? Putting t equals to 0. Now you can write it as, let's substitute t naught equals to m by mu. So I'll get mg by mu minus 4mg by mu into ln, what is this? M minus 4m by minus 4m. So this is, I'll just look at this part. I don't want to write the whole thing again. So this is basically minus 3m by minus 4m, which is just 3 by 4. 3 by 4. ln 3 by 4, I can write it as minus ln 4 by 3. Right? So minus and minus becomes plus. Finally, I'll get, we are solving for velocity, right? I can take mg by mu common. I will get 4 into ln 4 by 3 minus 1. This would be your final answer. Okay. Now you don't have to do it. You can just substitute this as some new variable and then proceed like that. That will also work. So if you take the other way is, if you take, let's say, the denominator as a new variable, let's say x, then the numerator becomes, what does that become? 4m minus x, right? And then you can proceed. Right? That will also be the same thing. Yeah. And then you can split it
last
into.
few steps again.
last few steps you can just, this is just calculation I've written. Yeah, just look at it. I substituted the limits, right? Upper limit is T naught, lower limit is 0. And yeah, so you get 0 minus 4m. And substituted what is T naught? T naught is m by mu. So plug that in. And you will get this. Here you will have ln minus ln 4 by 3. So minus and minus becomes plus. And then I took mg by mu common. That's all. Okay. Any other doubt in this calculation? Concept just ends here,
sorry,
right?
little silly
Ah,
doubt.
tell me,
Where
tell me.
does the mu come from in the second step? In the denominator,
Here,
the integration, yeah.
because I am integrating, this is actually, I have skipped a step here. I'm integrating mu t minus 4m and the variable is t only here, right?
Yes.
So there is a intermediate step here. You take mu t minus 4m as a new variable. Let's say you take it as u, right? You write it as this is equal to u, let's say. Then we'll get mu t minus 4m is equal to u. Differentiate it with respect to t, what will you get? Mu dt is equal to du. So you'll get dt is equal to du by mu.
Okay, so got it.
Right? So that factor mu gets divided here. I didn't do that directly. You can do this because it's just a linear function. So whatever the coefficient of t is there, you just have to divide by that. Okay. Please work it out. Do the calculations yourself once. You'll get it. Okay. The notes will be posted after class. Okay. Let's see. We have about 20 minutes left. Let's see if we can do at least 2 problems. Let's look at this one. Please read it and solve it. Okay, one response, two responses. You're saying T1 is greater than T2, means it will take more time in the first case compared to the second case. Again, can I ask what is your reasoning?
So basically, the acceleration and the how fast it's going to slip is going to be based on what's going to be like off the table. So in the
Okay,
first case, there
but
is more.
the acceleration will also depend on the total mass, right?
So that the total mass which is on the table is handled by the normal force of the table. So
No,
so
but it's the entire chain that is sliding off, right? When the so in the second
but
case, the mass that is hanging outside is more, but the mass on the table is also more, right?
it's a frictionless table, no?
Huh?
So the mass on the table doesn't matter that like the mass only off the table is going to give you the tension which is going to pull the rest of the rope.
Okay, but what is acceleration? Net force by mass, right? Net force is given by the gravity of the part that is hanging. But then
Yes.
you have to divide by the total mass of the chain. You following?
What I thought was that like it should be only the mass which is hanging off the table because that's the only
That
thing.
is the force that gives you the force. That is correct.
Uh,
But then you have to divide by the total mass, right? To get the acceleration.
yes, I didn't take into that.
So both will matter.
Yes.
Avnish is saying none. Interesting. Which means both will be equal.
Yes, sir.
Okay. Let's see. Nishant is also saying the same thing. Okay, let's work it out. Where is the... So this is like half of it is on the table, half is hanging out. So let's say at any time, let's look at the first case, right? Let's say this chain, some X length is hanging outside or off the table. So the force will be basically the weight of this part. So that will be X by L, or I can write M by L. Let's say mass of the chain is M and the mass of the two balls are capital M. Okay. So here I can write it as M by, let's say L is the total length of the chain. So M by L into X is the mass of the hanging part, into G is the force, divided by the total mass will just give me M, right? So this is your A1, let's call it, acceleration as a function of the length X that is hanging off the table. So I can write A1 is equal to X by L into G. Okay. In the second case, the same thing, but you have these two balls also attached to the chain. So the part that is hanging, let it again be X, but you have this mass also here, right? So the force would be M by L into X plus capital M into G, divided by the total mass of the chain would be M plus 2M, correct? This would be acceleration as a function of X, the length which is hanging out. Let's see if we can write it in a simpler form. Let's see, A2 is equal to, let me take X by L outside. Okay. So what will I get? M plus ML by X into what is this? XG by L divided by M plus 2M. Okay. But XG by L, this is just A1. Correct. So what will I get? I will get, let's write it as a ratio. Let's write it as A2 by A1 is equal to M plus ml by x divided by m plus 2m. Okay. Now, how can we compare these two? We just need to look at L by x and 2, right? It's given that the hanging part is half of the total length, right? And we are looking at this as it is moving, right? So we are always taking x by L to be greater than or equal to 1 by 2. Correct? What does that mean? This means L by x is less than 2 or less than equal to 2. Correct? So look at this here. This L by x is less than or equal to 2 and this 2 is just 2. That means the numerator as a whole would be less than the denominator, or at least at most will be equal when it is in the initial. When it starts to move, it will be equal. But as it is moving, as x increases, this numerator will become smaller compared to the denominator. Correct? So therefore, you will get A2 is less than A1. Correct? Acceleration in the second case would be less than the acceleration in the first case. So what can you say about the time? So therefore, T2 will be greater than T1, right? If it has to fall through the same distance, acceleration more means less time. So which one is larger? T2 is larger. Is this clear? Please ask doubts if you have any. I have written these accelerations as a function of the length of the part that is hanging. Right? So, and we compare the two acceleration as a function of x, we see that acceleration of 2 is less than that of acceleration of 1. We can put equal to, that is equal only in the initial case, but that's not what we want, right? We want the total time it takes to fall. So after it starts falling, x is always greater than L by 2. So we can ignore the equality sign actually. Okay? Fine. Let's see one more problem and then we can finish today. Okay, this one you can do. Anything? Okay, so in the interest of time, I'll just start solving it. If you get your answer before that, please feel just write it in the comment. Right. So first, no friction anywhere. We can find the acceleration of the masses. So this would be mg sine theta, and this one is, let's call this as m. So this would become 4m, right? So this will have mg downward. This is 4mg sine theta. So the net force acting on the system is 4mg into 1 by 2 minus mg, the force acting on the block here, this force on the ball, sorry, this hanging particle, divided by the total mass of the system, that will be 5m. So what will I get? This is just 2. So I'll just get m gets cancelled everywhere. I'll get 10 by 5, or basically I'll get g by 5, which is, taking g as 10, this gives me 2 meter per second square. That's the acceleration. Okay. The mass here is starting from rest. Let's say it travels a distance x. Okay. So at the same time, this particle will move up by the same distance x. Correct. So we need to find the shortest distance between them, right? So let's say this point here and this point here. This is the shortest distance between them. Let it be s. Okay. If this moved up by x, this distance would be d minus x, and this length is x. Okay. I'll erase this. What is this x? If it is starting from rest, I can write x is equal to u is 0. So just half acceleration is 2 into t square, right? So I'll just get x is equal to t square. Correct. The second equation of motion. Now, there are different ways you can do this. I will use the coordinate. I'll write down the coordinates of these 2 points, of this particle and this mass. So let's say pulley, you have the origin, right? This point will be equal to 0 comma minus of d minus x. So I'll just write it as x minus d, right? Yeah, that should be. Or I can say downward is positive. That also I can do. But let's keep it as upward as positive. So I'll get 0 comma x minus d for this point. Now this is x distance. This angle is 30 degrees. So I can say the coordinates of these points are x cos 30 comma minus x sine 30. Correct. Which is equal to x root 3 by 2 comma minus x by 2. These are the coordinates, right? Let's label this as A and B. So what is the distance between AB? So this distance AB will be equal to, we can look at directly, I can write S square is equal to, what is the difference between the coordinates? I'll get x root 3 by 2 minus 0 whole square plus minus x plus d. So I'll get d minus 3x by 2 the whole square. That would be the distance s squared, right? We need to find the minimum distance, right? And the time where the distance is minimum. So we'll differentiate it, right? Let's differentiate it with respect to x. So I'll get 2s into ds by dx is equal to this. What is the derivative? I'll just square it, no? So I'll just write it as 3x square by 4 plus d minus 3x by 2 the whole square. So this derivative is 3x by 2 plus 2 into d minus 3x by 2 into minus 3 by 2. What is the derivative? Equate it to 0. Right? So this gives me 3x by 2 plus, sorry, this is minus now, minus 3d plus 9x by 2. Is it correct? Yeah, is equal to 0. So this gives me 3 plus 9, 12 by 2, 6x is equal to 3d, or x is equal to d by 2, right? D by 2 means d is 2 meters, so x is just 1 meter, right? Or 1. Put this x back into, and we know that this is equal to t square, x is equal to t square. So from here, we'll get t equals to 1 second also. Put this x back into the expression for s square. What will I get? I'll write it here. S square is equal to 3 by 4, right? Root 3 by 2 whole square, 3 by 4, 3 by 4 plus d is 2. 2 minus 3 by 2 is 1 by 2. Whole square is just 1 by 4. So I'll just get 1 again. This means s is equal to 1 meter. This is your answer. Okay.
Excuse me, sir.
Yeah, tell me.
Sir, is there any way to directly calculate the distance between the particle and the body? Like using
Directly, this is directly only, right? I just wrote it in coordinate form and did it. What
sir,
else
like
can you?
just using the lengths of the, like, distance traveled by the body and the length of the thread, the distance of the particle from the pulley, like using those two.
But this will be some, see, this turns out to be exactly, so this is 1 meter, this is 1 meter, and this is 1 meter. It turns out to be a equilateral triangle. But that is after solving it, right? Before solving it, this would be some random triangle. So I don't think that would be a short way, right? After I solve it, I can see that this AOB is an equilateral triangle, and then I can basically figure it out. Yeah, I'm not sure what else you can do. I mean, sure, you can find some geometry, use some other property of geometry and figure out what this distance is in terms of the angles, right? But I personally found the coordinate way to easily find the distance, right? In terms of this x, because we know that this distance x that it travels up is the same distance x it travels on the inclined plane. So thereby I was able to find the distance, and that x is the variable, so I differentiate it, equate it to 0, and then solve it. Anyway,
Okay.
we are way over time, so thank you all for joining. Next week we are going back to class 12, right? We are looking at current electricity. That DPP was shared last week, I think, last Monday. So by next Monday, you should have solved it or at least looked at it. Okay. The level is easier than the level that you have for these DPPs. So far, what we have had so far. Okay. It's much easier DPP. Okay. See you all next week. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.